Assalamu alaikum. I'm fine. Okay. Sure. Mm. I was looking into the way I can design or go by your preparing your revision. So I gave you a hint that we'll be going through the quadratics today. So you revise that. Sure. Okay. Now this is a list of the topics in the chapter that they are giving you, making sure that you have to have the knowledge of all these things. Solving quadratic equation by factorization, I'm highlighting them, that's it. Then the completing square method is there, quadratic formula is there. Okay, so these are the three basic ways you can solve the quadratic equations, and normally the preference is given to the factorization, that's at number one. Then the students basically they go for the quadratic at the second place, and if not, and only if they've been asked to, they go for the completing square. Okay, so this is the kind of a precedence that they have about these three methods. Okay, but each one of these methods have their own benefits, pros and cons. Okay. Okay, then solving simultaneous equation, which is one linear and one quadratic. Okay, that is a part of this chapter, and it's exactly the same thing over here with 1.9 intersection of a line with a quadratic curve. You see, the the line with a quadratic curve is again a linear equation with a curve with a quadratic one. Okay, so these two topics are exactly the same thing. Uh, there may be a slight difference in a way that they put the question. For example, over here they will merely give you two equations and ask you to solve them out. But over here they may form a question in wording, like the line is crossing that curve at 2 points, find out the points of intersection, something like that. Okay, so there will be more wording into it. Okay, then we have this thing, solving more complex quadratic equation. Now when they say complex quadratic equations, they means that equations that can be reduced to quadratic. Okay, or what I used to call them quadratics in disguise. Okay, so they may look like any other power, but when you treat them in a proper manner, they can be reduced into a quadratic. Okay, and then maximum and minimum values of a quadratic function. This is something that you should know, that the maximum and minimum values are very important in the case of a quadratic. That's what we normally look for in quadratics. So how to find out that y minimum, y maximum, and uh, quadratic inequalities. Yes, so not always that you have equations, you have inequalities as well that you have to find the solution of, and the solution of any inequality is again a inequality, so it's a range. And finally, the number of roots of a quadratic equation. Now if you want to find out the number of roots of any quadratic beforehand without solving them, so you can get that is through the discriminant. Okay, so we work out the discriminant in this case. So these are your topics in the chapter. Now one way is that we can go through the miscellaneous or the review exercise that you have, but that was something that is from the book. You might have already done that end of the chapter review exercise. Okay, so I'll try to find out certain questions from somewhere else that you can try out. Okay, so to start with, now what you have to do is I'll give you certain questions where you can you have to basically uh, solve the given quadratics. Okay, so let me see. Okay, now this is not, it doesn't look like a quadratic at all. Okay, if you look at it, here we are. It doesn't look like a quadratic at all. It's a fraction with x being in the denominator. So can you try this out? Uh, by trying this out right now, I'll be writing and you'll have to exactly tell me what to do. Let's see if you can uh, phrase it out. Okay, you can tell me, express it, how to do it. Okay, then when I'll give you the questions as a homework, then you have to do them all and submit them back. Okay, so there you go. Right now you're telling me what to do. Mhm. Okay. Okay. Now I have objection on the way that you are telling me that cross multiply. Right now it will work. I'm not against that. Okay. Right now, if you cross multiply, like x goes over there times 15 and this whole bracket times here, that's fine because these two denominators are different. But suppose if they have anything in common, now then the multiplying or cross multiplying them won't give you the LCM. Okay, so normally what we are doing is we are taking LCM here in the denominator. Okay, so look for the LCM and then you figure out what to multiply in the numerator. Okay, so 15 will be multiplied with x and 10 will be times 2x plus 1. Okay, equals to 55 over 2. Okay, so next, now that cross multiplication is literally something that you'll be doing here. There we go. Because it's a fraction, you can't do anything else. So you'll be cross multiplying. 2 will go there and this x times this bracket will come on this side. Okay, fine. So 2 times this. Go ahead. What will happen here? You keep on telling me as much as possible. 20x plus 10. Okay. Okay. You could have multiplied that. I kept it outside for one step. There you go. And now I'll be multiplying it. 55x times this. So it would be 110x squared plus 55x, and it would be 30x times 2, 40x, 20, and now let's add them all. Okay, now my consideration over here is to keep this quadratic term positive. So it's like I'm bringing everything else on this side. So this will be positive. It's this side that I'm writing and moving everything else. So 55 minus these two, what will it be? Minus 15. This is 70. Okay, yes, minus 15x minus 20 equals to 0. Okay, is there anything that you can simplify it with? Obviously 5, yes. So you get what? Okay. Now you have to figure this out, that what's the factorization of this? How can you split the middle term? Okay, because this is to be done with the factorization. Okay, so factors will be formed 8 and 11. Okay, so you took 2 out of this and times it over here at 8, 11, and they have a gap of 3. Yes, difference of 3. Okay, so what can be taken common here? 11x, 2x. Okay, so the value of x would be half. Yes. Okay, fine. These are your answers. So you've done this. You see that first task was to reduce it into a standard form. If it is not in the standard form, you are not able to apply any of your methods to solve it out. Okay, so that's the first thing. Okay then. Now when we are through with this, okay, you can try one with the completing square method. Okay, so let's attempt a question based on that. Okay, if you're given an equation and you're asked to have the square completed, so how will you try that out? Let's see. Let's take a question from here. There we go. Recall your completed square with the help of this. Okay, there you go. Completed square. What will you do if you have to complete the square? Okay. Mm-hmm. Okay. Now this is something to be done on a sideline. The middle term is 45. Basically, it's a linear term. It can be placed anywhere. Normally, it is in the middle, but it can be placed anywhere, the linear term. Its coefficient is 45. You divide it by 2. Okay, 45 by 2. Then you also square it up. Okay. Okay, and then you add and subtract. Okay, now you can add and subtract. That will make your make one extra step basically over here. Okay, for you. So what you need to do actually is to uh, instead of adding and subtracting, try to write it directly in a whole square form. Okay, now what I would have liked you to do here is to rearrange it a little bit, putting the quadratic term first, okay, then the linear, and then the constant term like this. Okay, that will give you a good idea whether the quadratic coefficient is 1 or not, and if you need to take care of that first, you know, the quadratic coefficient being minus 14 here will make a issue, or it cause a problem for the completing square method. So you need to take this common. Yes, so you cannot try the go for the completed square without taking it common. So minus 14 is taken common ahead of the completing square. There you go. Fine. So there you go. What's left inside then? It's x square. This sign. Okay, go ahead. Tell me what to write here. X square. Hmm. By 14. Yes. X. Okay. So now your linear coefficient is already 45 by 14. Okay. 45 by 14. Sorry. There we go. That's a linear coefficient. So how will you take the half of it now? Mm-hmm. No, not to multiply it with 2. Multiply it with half. That's how you take the half. Okay. So it would be 45 over 28. There you go. And now when you square it up, you get 45 over 28 squared up. There you go. Okay, fine. So how will you write the completed square now? Hmm. Yes. No, it won't be plus, it will be minus, because this is the sign that is followed over here. X minus that half, 45 over 28, okay, all squared, fine, and minus the square over there. Yes, fine, 45 by 28 squared up. There you go. That's the whole square. Last step would be to open up the square bracket and multiply it throughout with that negative 14. So it's going to give you minus 14 x minus 45 by 28 whole squared plus, okay, 14 is multiplied with 45 over 28 squared plus 14. Okay, fine. Now this can be settled. It's a big number. I don't force you to uh, try it out without the calculator. You can just plug it in and find it out what the thing is. Okay, it's a big fraction. So 2809 over 56. There you go. So you see, this is how it's done. I well, randomly the question that was picked up had big numbers over here. So anyhow, uh, if the numbers are small, it's slightly easy to tackle them. But anyhow, the method should be clear that how the things are done. Okay, that's the whole idea. So this is the completed square method. The quadratic formula is perhaps the simplest one. Okay, so there's no issue about it. I think so that when the time comes, we'll try that out. Now we come to the questions where you have to solve the two equations simultaneously. Okay, one being linear, one being quadratic. Now, challenge in this sort of questions is mostly that if you're not given the equations and you have to form one, okay, that's the issue. So that becomes challenging. So I take one question where the answers are given perhaps over here, and you have to prove that they are these are the solutions. Okay, so you can see that they're phrased out in geometric form, that the line is crossing or meets the curve at this at 2 points. Okay, so you can see it's a quadratic curve. Okay, a line is crossing it at 2 points, so it must be a case something like this, a curve being crossed by the line like that, and 2 points A and B, the intersection points are there. Show that the coordinates of one of the points is this and find the other. So definitely we'll have to find both of them. Okay, so how will you go by solving it? Now you tell me. Okay, since y is the subjects, yes, we can equate them. 6x plus 1, otherwise it would be the substitution. Okay, wherever the y is in the other one, you just substitute it with the expression of x. Okay, now you have to tell me what the next step is. Okay, I'm directly subtracting 2x minus 6x, 3 minus 1. Okay, then okay, you remember the formula? Okay, keep telling me the values that I have to write. Not negative 4? Mm. Okay, fine, fine. Root, that's 16 for AC. A is 1 and C is 2. So it's going to be 2. Okay, over 2 times A. That's 1 as well. So it's 2 only. Okay, fine. So plus minus 16 minus 8, that's root 8 over 2. Definitely 2 can come out. I can write it like this, 4 over 2 plus minus, from here I can write 2 root 2. 8 can be written as 2 root 2 over 2, which leaves me with the values 2 plus minus root 2. There you go. Okay, so you can leave them as they are. If there's any, oh, we need to find out the coordinates. Pay attention to this. Y as well, yes. So for that, take the expression from the linear one. Y equals to 6x plus 1. And if you're using this exact form, so it's gonna be 6 times 2 plus minus, so it's gonna be 12 plus minus 6 root 2 plus 1. So y is gonna be 13 plus minus 6 root 2. And you see there was no swapping or switching in the signs. So for the positive one, this one 2 root 2, it will be 13 plus 6 root 2. For negative, it will be negative. A good way to give the answer is write the coordinates in x comma y form. Okay, so you're gonna have 2 plus root 2, 13 plus 6 root 2. Okay, or the second one is 2 minus with a 13 minus as well. There you go. Fine. Okay, so we have solved them simultaneously. The next one is solving more complex quadratic equations. Okay, now as I said, hello, are you there? Okay, fine. So as I said, that in the more complex cases, there are equations which have to be reduced to the quadratic form. Okay, the ones that I think so they are difficult to tackle are something like this. So I give you one of these. There you go. So try them out. Here we are. Yes. So you're telling me what to do with them? Mm-hmm. Okay. Okay. So that's gonna give you. Sorry. X plus 1. Where are you getting this 1 from? Oh, you know what? That's absolutely wrong. I guess there is some disturbance. You're not having your focus here. There you go. 12 times 3 times x. You know, these two numbers cannot be multiplied together. Okay? Can you hear me or you're offline? There is message keep on coming here. Can you hear me clearly? Uh-huh. Hello? Okay, yes, I've changed the connection. Okay, so there we are. So now I was saying that there is some noise behind. I'm not sure if you're able to keep your focus, huh? So please get focused here. Okay. So you see that these two numbers cannot be multiplied. You multiplied 12 with the base while the power was still there. You cannot do that. Okay, if I give you example, 2 to the power 3, if I ask you to time it with 3 to the power 4, you cannot multiply them. Okay, their bases are different, the powers are different. Even I cannot multiply them with any other whole number. Like if I ask you to multiply them with 5, I cannot multiply. Okay, numbers can only be multiplied if they don't have the index on them, or the index is the same. If the index is same, like 3 to the power 4 times 3 to the power 3, yes, it will give me 3 to the power 7. Okay, so this 12 will remain the coefficient of 3 to the power x. There's nothing that we can do about it. So writing this was wrong. Make sure you have noted this down. Okay, so if you cannot multiply them, then what's the way forward? What will you do then? 3 to the power 2x, 12 times 3 to the power x, and then 27. Okay, this is the code. Even if you take 3 common, and if it was possible, just taking common out of the out of the two terms. For example, I took something common. I'm not sure what your thinking is common. Is it a single power x or a double power x? Yes, single power x. Okay, if I took that common, what will be left here then? Okay, so you're saying it will be 1 to the power x. Is it so? Mm-hmm. Rida? Okay, and over here it's 12. Now there's a big error over here, big problem, this one. Okay, this is wrong. So when you take 3x as a common, taking common means that you're dividing. So what you're actually doing here is 3 power 2x is being divided with 3 power x. Can you settle these two together? Tell me what will happen. So what do you get? 2x minus x. It will be 3 to the power x. You see, if you would have taken 3 to the power x common, so you will be left with a 3 to the power x because there were two of them. This power 2x means that there were two of the 3x over here. Look, 3 to the power 2x literally means there is a 3 to the power x times 3 to the power x. There are two of them. That's why the power gets added and give you 2x. So when you take one of them common, the other one is left out. Think of it like this. It was a 3x squared. Okay? It's a 3x squared. Think of it like this. So if it was a squared one, you took one common, so the other one is left here. Okay, so make sure you understand it. Okay, if you divided it or if you have thought of it like this anyway, you would have got the right thing. But this 1 to the power x is absolutely wrong. I'm leaving all these mistakes so that you, when you get your this write up, so you should be clear about it. Okay, so anyhow, you were telling me that you took it common out. Now you decided that it will be 3x and minus 12 definitely plus 27 equals to 0. Now what do you think so to do next? Okay, I'm basically telling you that it's a good, or it's tempting to take common out of the two where you see the two things being likely to have a common, but you're left out with this one. What to do with it now? No way forward. So you see, taking just this one common out of the two terms is not a solution. Okay, so any more ideas? Hmm. Okay, yes. Any other way you can think of solving it out? Yes, Rita. So I wonder that. Okay, now the thing is that these are quadratics, and quadratics, it's not a specific topic, it's something general. You can encounter them anywhere in your A2 as well. So this is something that you should know how to solve out. So there you go. The thing that you have failed to identify is that this is something that can be reduced to a quadratic. Look here, the terms that you're looking over here, 3 to the power x and 3 to the power 2x, they are basically one is the square of the other. Okay, as I told you, think of 3x as this, 3 to the power 2x as this. It's 3x squared. So when this is 3x squared and this is 3x, let me write it like that, 3x squared, and this is 3x. That means one of the term is a linear of 3x and the other one is its quadratic. So you have a linear and a quadratic term around. It's only that they look slightly different. It's 3 to the power x, but they can be treated as linear and quadratic. So for the time being, you can just hide them, 3 to the power x with a y. Just hide it and make it a quadratic. There you go, y square minus 12y plus 27. There you go. It's hidden. What's inside y, we hide it for a while and it becomes a quadratic. See? Now you can spend your focus on solving this quadratic, and once you have the two values of y, then you can turn it back into 3x and try to solve this out. So can you give me the solution to this one? What is it? Mm-hmm. 9 and 3. Is it? Okay, 9 and 3. So this is 3, this is 9. Once you have these values, you can turn it back into 3 to the power x. There you go. And you can treat this as 3 to the power 1. And this is 3 to the power x, and this 9 can be treated as 3 to the power 2. And there you have the values of x. X is 1, x is 2. See? So you have to visualize this, that this is a quadratic in disguise. One of the term is linear, the other one is the quadratic of the same expression. That's the thing. Okay, so as I said, this is something that gets challenging, huh? So, okay, one other that I can spot perhaps is this one. Here we go. The things in square or in square root, they get equally difficult, you know. That's one of the equation, and perhaps I can also ask you to solve one of these like in a root like this one. There are more challenging ones around, but we can take up these two. There we are. Okay, so let's try out these two. What will happen then? Okay, okay. Mm, fine, you can multiply it. It will be times x4 minus. Okay, okay. So is it quadratic? Like y. So it becomes a quadratic. Y square minus 4y minus 2. Okay, that's enough. So I think so you manage this. Now look at this one now. No, not at all. In fact, you should just move these terms on this side. T minus 3 root t minus 10 equals to 0. And let me share with you. Can you see that one of them, this root t and the t, they're already one is square of the other. Okay? So over here, the substitution that you need to do is that root t taken as your y. Okay? That will automatically, when you square up, gives you t equals to y square. There you go. So your equation turns into a y square minus 3y minus 10. There you go. See? So it's like this. You can complete this. I just wanted to share that how the substitution is done with these ones. Okay? Fine. Okay. Now when you have these uh, quadratics uh, there, it's important that you should know that how we can spot the maximum and minimum value. Okay, so it depends on in what way the equation is given. If the equation is given in completed square form, it's literally very easy to find out the the turning point or the vertex or the value, okay, of the turn maximum minimum value. So there you go. Okay, so tell me in this one that if you have this first one as your given completed square, what would be the turning point in this? First of all, you have to tell me the type of the curve, because type is knowing the type is very important, whether it's curve up or curve down. This is curve up, this is curve down. So what's the type? Curve down, fine. The other one is curve. Fine, got it. Clear. Now you try on telling me the turning point. Yes, the vertex. Mm, you're right. Good. Mm, minus 1. That's good. Got it. Clear. Okay. So if I ask you, if it is a cup up curve like this one, it must have a minimum point, is it? Okay. So minimum point means it must have a y minimum as well. What's the value for that y minimum? 5. Got it. Good. And if there is a cup down one which has a maximum 1, so what is the maximum value of the function y max? Minus 4. So remember that this value of function at the turning point is the maximum or minimum accordingly. Okay, fine. So you see that if the thing is given in a completed square, it's easy. Otherwise, if they ask you to find out from a equation like this, then you have to either turn it into a completed square, or you have to change your method or approach. Okay, so like in this one, in these questions, if they ask me to find out the turning points or the vertex, so one of the approach can be that I go for the completed square. Okay, completed square. So you already know how to turn it into a completed square. Okay, we tried this out. Okay, the other approach would be then I actually find out the roots. Okay, that roots or the x-intercepts. Now if I can get the x-intercepts, even that can give me the turning point, you know. So do you have any idea about how to get the turning point from the roots? Completed square is simple, but roots. Okay, how will you find out the roots? Okay, first thing, one thing at a time. Roots mean, okay, you can factorize, but basically you'll put y equal to 0. Okay, so your equation 2x square minus 3x plus 3 will be placed equal to 0, and then you'll try to solve it out. I don't ask you to factorize it, but go ahead, get the roots from the calculator, because right now I'm just interested in telling you the method how to get the turning point from this case. So it's 2, -3 and 3, giving you, oh, out of nowhere we got imaginary roots. That means it doesn't cross it. There are no real roots around. Okay, no real roots in this case. Okay, how will you identify it from the calculator? If you have solved it in the calculator, your roots are coming like this: 3 plus root 15 with the I written over there. Can you see that I? Spot that I. This is basically an imaginary number called iota. Okay, iota. So if you see that around, that means the real roots are not possible. So that's why. Okay, so then we go to the other one. Let's try the other one that we have. And the third one. 1 minus 3 and 6. Oh, that's also imaginary. Oh, so forget about it. So these examples are coming or giving us imaginary ones. Now what I wanted to do was, I wanted to get the roots, and just sharing with you in general that if you got the roots like this, x minus alpha and x minus beta for any y, that means that you know that the curve is crossing at alpha and beta. These are the roots. So in that case, in a factorized form, and when you know the roots, the vertex actually lies at this line of symmetry. Okay, and that line of symmetry happens to be exactly halfway between alpha and beta, the roots. So what you do in order to find out this equation of the line of symmetry, you take the average alpha plus beta by 2. Remember that? Okay, and when you plug this value into your y, you get that y minimum from the equation. Okay, so this is something that I wanted to share with you. I never got the right equation, but I can make up an example for you. There you go. Let's consider that it's the equation y minus 2, x minus 2, x plus 3. Okay. So what are your alpha and beta? The alpha would be minus 3 and beta is 2. Actually, I placed them in order. The negative one being first, alpha, and the positive one being beta. Okay. So the equation of the line of symmetry is minus 3 plus 2 by 2. That is negative half. So x equals to negative half. It's not only the x coordinates of the vertex, but it's also the equation of line of symmetry. Okay, line of symmetry as well. Okay, this one. Fine. And it's also the x coordinate of x coordinate of vertex. Okay, both the things at the same time. Now if you want to find out the y minimum, okay, because it's a cup up curve, y minimum, so you go and put this back into the curve. So minus half minus 2 and minus half plus 3, both of them are going to give you 2.5, but this is 2.5 or 5 by 2 in negative. This is 5 by 2 in positive. So you're going to have a y which is negative 25 by 4, which comes out to be, I guess, 6 fours are 24, is it? So it's 4 point, no, oh, 6.25, yes, negative 6.25. So there you go. The y minimum, okay, because it's a cup up curve, y minimum is minus 6.25. So this is another approach. You can find the turning point or the y minimum from the the equation which is in factorized form. Okay, clear? Fine. Now what do they ask you on these curves? Probably they are asking you to form the equations. Is it? Match each equation with the corresponding graph. Okay. They are asking you to match them. Okay. Now, can you match them? Literally going for these. Okay. Let me. First one goes with A. Can you give me the reason for that? There we are. So this is the only cup down. That's the reason. Okay. So since it's cup down, you said it's with the part 1. Okay, fine. This one. There's no big calculation. Nope. It's the number 3. How do I know? Look at the y-intercept. 6. What's the y-intercept here? Okay. So the y-intercept is the same. That gives me the confirms that which one is this. Okay. And the second one here with the y-intercept 3, you can see the 3 over here. Fine. Okay. Now, okay, so I think so we can spend some time on solving the quadratic inequalities. Okay, the idea for solving the quadratic inequalities is simple. When you have uh, equations like this, now the challenge in these is that you actually have to put them in the standard form. So I'm not going for any one that is not in the standard form. So let's just consider one or two which are given in a standard form already. Okay, like if you are asked to solve, they're saying solve the following inequalities. There is a linear one and there's a quadratic one. Okay, so we can try solving these ones on their own, and then there's a follow-up question as well. Not sure if we can take that up. Have a look. Solve the following inequalities. Okay, so this is a simple linear inequality. Can you see? Solving a linear inequality is not a big deal. So tell me how to do it. 7x minus 5 less than 3x plus 5. Simple, one or two steps. Okay, so it would be 4x. Yes, 4x less than 10. So x would be less than 10 by 4. That can be, there you go, simple. Nothing big, nothing difficult. Simple, straightforward equations. Now, when it comes to solving the inequality, although 2x square minus 7x less than 4x minus 5, first thing you have to do is turn it into a standard form. So bring them all on this side. 2x square minus 11x plus 5. Now for a while you need to get the roots, like you're solving a equation. Okay, so that I'm right now just getting from the calculator. Okay, because I don't want to spend the time into these factorization. My idea is to convey the method for solving inequalities. So the values are 5 and half. So one of the roots is half, the other root is 5. So you know, once you know the roots, you actually know that this curve is crossed by the x-axis at these 2 points, half and 5. And then it depends on what you're actually solving for. Over here we are solving for y negative. Your curve is below the x-axis. See? So when yes, so we take the part which is below the x-axis, and it happens to be the middle one, this one. So you write this interval. It's a single interval. So you imply your result from here. Yes. I have a objection on the way that you're reading it, you know. Fine. It's not read as half less than x less than 5. A good way to read it is that x is from half to 5. Okay, be a little elaborate. Okay, x is from half to 5. There you go. And if they were included, we would have written that half, both included. Okay, both inclusive. Okay, so right now we can make it clear right now as well that both exclusive. Okay, that means they are not included in the interval, you see. So there you go, that's the solution for the negative one. And if we had the equation coming y more than 0, y positive, so in this case it would have been the tails, these two, where y is positive, this one and this one. So the solution for it, I'm just writing the solution in case. So yes, you're right, x is less than half or x is more than 5. So these are two intervals, that's why they're written in two inequalities. There you go, these two. Fine. So there's nothing big about solving the quadratic inequalities if you know the roots. Okay, so that was the thing. And now the final thing about the discriminant, that if somehow you know that a line and a curve are crossing each other, or I just say the quadratic equation has how many roots or what type of roots, so you can just find it out with the help of a discriminant. Okay, so let me just take one equation, and or I can take a difficult question like this, like this one, having no real roots. So if they tell you that this particular quadratic equation has no real roots, no real roots, that means yes, its discriminant is negative, is less than 0. So that's what you have to just do. But before that, identify your A, B's and C's correctly, because if you make an error there, it's gonna go or spoil the whole solution, you know. So there you go, A, B's and C's, I've highlighted them. So when they say A, B, C, so the discriminant is b square minus 4ac less than 0. So it would be negative k plus 3 whole squared, although it's negative k plus 3 whole squared, but this negative is not gonna do any problem. When squared up, it's gonna go away. So minus 1 as well. There you go. So make sure you expand them properly, because this is a very problematic thing. They expand it without applying that identity, and it's really terrible. This sort of mistake over here. So 4k, there you go. So this makes a quadratic inequality in turn. 10k plus 9. There you go. So you solve it just like your quadratic inequality a while ago. So you find out your k, the roots. Okay, let me get them. 1, 10 and 9, minus 1 and minus 9, minus 1 and minus 9. So your k curve is basically crossed at minus 9 and minus 1. Do put them in the right order. The smaller one is here earlier, and then the larger one. So it's a negative, so it's again this interval, the central one, this one. So your solution is that k is from minus 9 till minus 1. There you go. Okay, fine. So here we are nearly, as I said, 1.9 is the same thing as 1.4 simultaneous equation. So we have gone through a quick overview of this. Okay, now I'll be sending right with the uh, write-up of this. I'll be sending you an assignment. Okay, so you try that out, and you have to submit it. Okay, by tomorrow, because we're gonna have the class not tomorrow, on Friday now. Okay, so you have the time by that by the next class, that you can submit it. Okay, fine. Okay then. So that's it for right now. Okay then. Allah Hafiz.